We all think the story of AI is about code, right? But what if that's not the whole picture? What if we're actually watching a much older story play out, a primal story about life, evolution, and the raw fight for survival? Only this time, it's not written in DNA, it's written in data.
Yeah, it's a pretty wild idea, I know. But once you start thinking about it that way, it just completely changes how you see everything that's happening right now. Are we just building better tools? Or are we, maybe without even realizing it, sort of midwifing a whole new kind of species into existence? To even begin to wrap our minds around that, we've got to look at AI through a totally different lens, the lens of evolution. And you know what? It turns out we're not the first people to have this thought, not by a long shot. Decades ago, this brilliant author and philosopher, Stanislaw Lem, he saw this parallel perfectly. He made this incredible argument that technology doesn't just get invented, piece by piece. No, he said it evolves. It follows the exact same dramatic, sometimes even ruthless patterns as any living thing on this planet. And when you look at the story of large language models, wow, his theory just maps onto it almost perfectly. Just think about it for a second. How did they start? It was kind of hurried, uncertain, right? Like the very first specimen of a brand new species. The earliest AI models just sort of appeared in research labs. There was no big announcement. They were primitive, a little clumsy, and honestly, hardly anyone even noticed. And what's really fascinating is that they weren't created out of thin air. They showed what Lem called inventive inertia. Basically, they built themselves on the bones of what already existed. You look at those early models like recurrent neural networks, and you see they borrowed heavily from old ideas about language and computers. So it was really more of a remix than some total revolution from scratch. So for a pretty long time, these early AIs were just kind of hanging out in this semi-secretive state, basically vegetating inside labs. They were total underdogs. I mean, they could barely compete with the big established species of the time, the huge, powerful search engines that were perfectly adapted to the internet as it was back then. And for these new kind of primitive things to ever have a real shot, it wasn't enough for them to just get a little better. Nope. The entire world, the whole environment around them had to change. I mean, think about it. Any new form of life needs an opportunity, right? It needs some kind of empty frontier to go out and conquer. And then that shift actually happened. The catalyst? It was the invention of the transformer architecture. And listen, this was not just some minor tweak. This was a seismic event. It created this huge, unconquered space of possibility. And it just so happened that these models were almost uniquely designed to fill it. Just like that, boom, the rules of the game had completely changed. And whenever a species finds a wide-open frontier like that, biology tells us something pretty incredible happens. It's a phenomenon called evolutionary radiation. It's this sudden, explosive diversification where one successful blueprint rapidly splinters into a ton of new forms, and they all just race to fill every possible nook and cranny of that new space. And that is exactly what we saw happen. It was like the Cambrian explosion, but for AI. Suddenly, it wasn't just one or two little experimental models anymore. It was BERT, and then GPT-3, Claude, Llama. I mean, a whole ecosystem of new intelligence just seemed to burst into existence. And every single one was just a slight variation on that ridiculously successful new transformer design. So as this huge expansion was happening, the models started to mature. You could say they started to grow up. Those early kind of awkward flaws, what Lem would have called the remnants of primitivism, like their habit of just making stuff up, hallucinating facts, well, those things started getting engineered out. They were replaced by much more sophisticated systemic solutions. These things were even developing new senses, learning how to see images and hear sound. And all of that, well, it brings us right here to today. This new form has become so successful, so totally dominant, that it's done something only the most successful species in history ever get to do. It's given its name to our entire epoch. We are all now living in the AI era. And right now, its reign feels absolute. But here's the thing about evolution. It never, ever stops, especially when you're at the top. The environment is already shifting again. New pressures are building up, you got the insane cost of computation, the physical limits of our hardware, the sheer amount of energy these things devour. So even now, at what looks like their peak, a brand new, maybe even more intense struggle for survival is just getting started. And looking ahead, it seems like two very different evolutionary paths are starting to open up. Path number one is just pure brute force gigantism. This is kind of the main branch of the family tree right now. We're talking models like GPT-4 that are just getting bigger and bigger and bigger. They're like the dinosaurs of their age, using their immense size as a defense strategy just to intimidate and outcompete everyone else. You know, the history of the car is actually a perfect way to think about this. That first path, gigantism, that's like building a massive multi-ton SUV. It totally dominates the highway, right? It's a status symbol, it's a form of protection, but there's a whole other way to evolve. Think about a tiny specialized electric delivery van. I mean, on the open highway, it would get crushed, but it absolutely thrives in those narrow, crowded city streets. A special little niche where that giant SUV is just clumsy and totally useless. And that right there, that's the second strategy we're starting to see, branching out. Instead of just getting bigger, new forms are evolving to be smaller, faster, more specialized. They're creating what you could call lateral branches that are moving into what Lem called peripheral environments, basically places where the giants can't easily follow. And this branching seems to be happening in a couple of different ways. First, you've got hyper-specialization. These are models evolving for really specific jobs, like in medicine or law, or just for writing code. And then there's this other thing you could almost call dwarfism, the rise of small language models, or SLMs. These are the little guys designed to live right on our phones and our laptops, far, far away from the giant server farms where the titans are locked in their huge, expensive battles. So this gets us to the crucial point. Lem's whole framework gives us this kind of chilling prediction for what could happen next. The giants, that main branch that grew so enormous as a defense mechanism, they could find that their massive size actually becomes their undoing. It could lead them straight to extinction. But the descendants of those smaller, more nimble lateral branches, well, they'll likely just keep on going, almost unchanged. They'll be the quiet survivors, the lasting proof that this incredible evolutionary explosion even happened. Which, of course, leaves us with one heck of a fascinating question as we watch all this play out. In this new digital ecosystem, who are the dinosaurs doomed by their own massive success? And who are the small, clever mammals just waiting to inherit the world?